Welcome to Integration B training. In this video, we're going to go through hyperbolic trigonometry. So a lot of the times, in most calculus classes, they don't really teach you hyperbolic trig, but in Integration B, you're gonna have to learn hyperbolic trig because it comes up a lot. It's in MIT, Harvard MIT math tournament. I don't know where other, UC Berkeley in Integration B, but yeah, you're gonna have to learn hyperbolic trigonometry, and so in this video I'm gonna sort of introduce you a little bit to it. Mainly is the stuff that you only need to know for this sport. Now, you just need to sort of memorize two functions technically, and that's just hyperbolic sine or sinh, and then hyperbolic cosine or cosh. So this function is in terms of exponential functions pretty much. So this is equal to e to the x minus e to the negative x, and then over 2. And then for cosh, it's e to the x plus e to the negative x over 2. Okay? And that's all it is. And so pretty much it's a little easier with trig functions because when you derive it, the derivative of sinh of x is cosh, and the derivative of cosh, it goes back to sinh x, right? There's no alternating signs. It's always positive. The reason why for regular trig it alternates sign is because in regular trig functions it can be put in terms of exponential functions, but the thing is they have imaginary numbers. So because of this, that's why we start having this negatives because of this imaginary number. Because we don't have imaginary numbers in hyperbolic trig functions, it doesn't alternate signs. So if you're wondering, okay, well, what is tanh? Tanh is everything else is pretty easy. It's the same thing. Sinh of x and cosh of x, and that's all that is. Okay, so this is what hyperbolic trig is. It's pretty much in terms of exponential functions. Instead of like sine square plus cosine square is equal to 1, it's a lot different. Well, it's a little different, but it can be a little tricky at first because it's weird. It's very weird. Sinh square plus 1 is equal to cosh square. That's the thing. Okay, and so when you see something like cosh square minus sinh square, it's not it's not cosh 2x or anything. This is equal to 1. Just be very careful with that. And it's also like the same thing with like hyperbolic secant. It's the same thing. It's 1 over cosh. Hyperbolic cotangent, hyperbolic cosecant, it's the same thing. I'll sort of guide you through all that stuff. Okay, so again, it's a little easier with hyperbolic trig. You don't have to use like Weierstrass for this one, right? Unlike the regular trig functions where you're gonna have to use Weierstrass or something else. But here, this is actually an identity. Sinh of x plus cosh. If you sort of look closely, this is, if you remember, it was e to the x minus e to the negative x plus e to the x plus e to the negative x. And this cancels out, you get 2 e to the x over 2, this cancels out. So this identity here, this is equal to e to the x. Okay, so that's also an important identity to keep in mind. this is just e to the negative x dx, and so the integral is just negative e to the negative x plus c. Alright, are the derivatives the same? Yes. The derivative of tanh is equal to hyperbolic secant square. So, of course, you know, let u equal 1 plus tanh of x du is equal to hyperbolic secant square. This is, you know, you end up getting 1 over u du. This whole answer is just ln of 1 plus tanh. What do we do now? So let's kind of remember. Let's see. Sinh square plus 1 is equal to cosh square. Okay. Then sinh square is equal to cosh square minus 1. Okay. So maybe with some ideas, maybe we can sort of do some conjugation here. It would be cosh x plus 1, top and bottom, so that we can make that bottom sinh square. Okay, so then we get cosh, here I'll just do that, cosh x plus 1, and we got sinh square. Okay, cool. Then this is now an easy integral. Let's see, cosh, or I guess you can put it as hyperbolic cotangent, hyperbolic cosecant plus, and then hyperbolic cosecant square. Be very careful. You still need to use negatives for this. So again, yeah, like the derivative of sinh x and cosh x, you don't really need negatives, but with hyperbolic cosecants, you still need negatives. So this is equal to negative. It's like the same thing as our derivatives. You know, this is hyperbolic cosecant x, and then minus hyperbolic cotangent of x, or coth. I don't know how you would pronounce this, but yeah, it's very almost kind of the same as regular trig functions. So what do we do here now? Well, I mean, you could just integrate by parts. So we could just do integration by parts. Again, it's very easy. You don't have to worry about alternating the signs, right? So you just dive straight into this. Okay, so then this is just x cosh x minus sinh of x plus c, and you're done. Okay, very easy. Okay, so now what about sinh of 2x? For hyperbolic, it's also the same thing for regular trig functions. So sinh of 2x is also equal to 2 times sinh x cosh x. So you could just sort of simplify it like that. So this becomes the integral of 2 cosh of x dx. And so now this is equal to 2 sinh of x plus c. Tanh. Well, again, we could just put it in terms of sinh x cosh x, and it becomes a little obvious that this is just a basic u substitution. I'm just gonna go dive right into it. This just becomes ln of cosh plus c. Okay, so now we have sinh of 4 cosh 3. All right, so this is starting to look like trig integrals, right? But with hyperbolics. So it's pretty much the same concept. In this case, we're gonna take out cosh, in fact, I could actually abbreviate this because we know we're dealing with hyperbolics. So I can abbreviate this. And remember that cosh square is equal to 1 plus sinh square. And so we'll take cosh out and then use the cosh square as 1 plus sinh square. And then when you let u equal sinh of x, and then you end up getting u for 1 plus u square, and then this just becomes power rule. So now we get, I can just write it down, sinh 5x over 5 plus sinh 7x over 7 plus c, and you're done. Okay, so it's the same concept like trig integrals, except that we're dealing with hyperbolic tangents and secants. So now you're probably thinking, what trig identity do I use here? First off, let me just remind you, the derivative of hyperbolic secant x is hyperbolic secant x tanh. Okay, and then we can maybe sort of use tanh square, sech square, and then use this as our du. But what is tanh square? What can we? How do we convert that? Well, let us use this equation here. Sinh square plus 1 equals cosh square. Now I need tanh square. So to summon tanh, I need to divide everything by cosh square, so that this becomes tanh square. Okay, so I'm dividing both sides by cosh square, and I end up getting, oh wow, this is tanh square plus sech square equal 1. Surprising, isn't it? So pretty much we end up having 1 minus sech square, and then sech square here, and then you use this for du. I'm just gonna, dive right into it. You end up getting 1 minus u square, and then this becomes sech cube over 3 minus sech 5 over 5 plus c. Yeah. What do we do here? I mean, you could simplify it pretty much. 2 sinh cosh 1 plus sinh to the power of 4. I think you already get the gist of this. This is, let u equals sinh, but I'm going to let u equals sinh square, so that du actually ends up being sinh 2x. And so now what you actually have is you just end up with du 1 plus u square. This is inverse tangent, so you end up with inverse tangent of sinh square plus c. Okay, so what do we do with tanh square? We can bring up that identity again, right? We had 1 minus sech square, right? And this is, the integral of this is just tanh. So we could just dive right in. Oh, this is just x minus tanh x plus c. Ooh, what do we do here? This doesn't look like hyperbolic trig at all. But technically, you can use hyperbolic trig. I mean, if you try to do it algebraically, right? You can do it algebraically. You would just do like what? E to the 2x, and then you get e to the 2x plus 1 squared, right? Absorption. And so what that does is you can just do a u substitution. You can let u equal e to the 2x plus 1, right? And then don't forget that this is 2e to 2x, so you would have to do like a half 1 over u square, and you get like 1 over, let's see, you get this plus c. So I mean, that's one way. You can do it algebraically. That's actually not bad. It's a little hard for some people to do this method because you're kind of doing an absorbed exponent there. The textbook way, though, the textbook way is well, I wouldn't consider this textbook method, but pretty much this is hyperbolic secant. If you know that cosh x is equal to e to the x plus e to the negative x over 2, then you know that hyperbolic secant is the reciprocal, right? It's the reciprocal. And it looks just like this, except that it's being squared. But be careful, when you square this, you square everything, which means that you need a 4. So I need a 4 here, so it's 4 here, 1/4 here. Okay, I'm pretty much multiplying top and bottom by 4. Okay, so then this is 1/4 integral of this. And I mean, we know what this is. It's a simple integral. This is just 1/4 tanh x. Ooh, now we have a definite integral. So how do we solve this? Is there anything sus about this? Obviously the bounds, right? So is this an odd function? Well, let's see, you're probably thinking, well, sinh is equal to e to the x negative x, right? If you put let x be negative, then we get negative here, positive here. Technically, yeah, you do end up getting negative sinh of x. So yes, this is an odd function, but what about cosh? Is cosh an odd function? Because if they're both, if this is odd and this is odd, then this is not an odd function. We have an even function, right? So is cosh even? Is cosh even? Just by looking at this, you can already tell, yes, this is even, right? Negative here, a negative here makes this positive, but I mean, addition is commutative, so cosh is an even function, sinh is an odd function. So this whole thing is an odd function. So this integral is just equal to 0. X over cosh square. Well, I mean, we could just, our first instincts, x sec square. Okay, and then oh, okay, integration by parts. Let's go. Okay, well, this is sec square tanh of x. Tanh of x, integrate tanh of x. That's, well, this is s over c. Oh, this is ln of cosh. Right. Okay, and then you're just sort of good to go. So this is just x tanh x minus ln of cosh of x plus c, and you are done. Now this looks weird, right? But this is just integration by parts. However, we might have to do a recursive integration by parts. So let's go ahead and get into that. Sine of x, cosine of x, but this becomes negative, negative sine of x. And then here we know it's just sinh x, cosh, then sinh again, right? And as you can see, we end up as recursives. So this is I equal sine of x, cosh of x, and then minus cosine of x, sinh of x, and then we have the minus I. We can add that, you know, we just add this, we get 2i divide everything by 2, and so you end up with just this whole thing right here, plus c. Right, so that's all that is. Now what's this integral? Ln sine of x, because the derivative is cosine of x, and then plus cosh, because we know we don't need that negative, right? So yeah, just a simple u substitution on this one. Is this integral of cosh square? No, it's not, right? You have to be very careful with trig identities. Sinh square plus 1 equals cosh square. Divide everything by cosh square, we get tanh sech square equals to 1. Aha! So what's actually going on is we're going to have to multiply top and bottom by sech square, and with this one we have to do 1 minus t square. So when we let u equal tanh of x, right, we're going to have to end up getting u square plus 1 minus u square, and then here you're just going to have to do partial fractions on this one. Yeah. So this looks like a weird, awkward integral. Let's see, we know that ln sinh, if we derive that, that's what, cof? We can actually, I think if we do this, it's kind of easier to see. I think you know where this is going. This is product rule, reverse product rule. What that means is this just simply ln of sinh x, ln cosh x plus c, and we're good. Okay, so again, it looks very weird, but we know this is cosh, right? In fact, you can sort of go like this. We know that this is e to the x plus e to the negative x divided by 2, but you can multiply 2 to both sides, so you can literally just substitute this in at the bottom. So this gives us sinh x to cosh x dx, and this is just simply half ln cosh x. Alright, another weird looking one. Again, it's just hyperbolic trigs. Here, I would multiply top and bottom by cosh, and we get, I'll just abbreviate this. I guess I could just abbreviate it. We're dealing with hyperbolic trig anyways. C square plus 1. And you know sinh square plus 1 is equal to cosh square, so we could substitute that, and this would give us cosh at the top, sinh square plus 2, and then if you u sub sinh of x, I'll just sort of go fast here. This is just square root of 1 over root 2 inverse tangent of sinh of x over root 2. And that's it. That's all the basic hyperbolic trig integrals. You'll get used to it very quickly. It's actually not that bad. Again, you don't really learn it in class, but this, if you really want to get into like very competitive integration B, you're gonna need to know hyperbolic trig. So yeah, I hope this is very helpful, and I'll see you guys in the next part.